Hello, welcome to Operations Management. In this lecture, I will talk about line balancing. Firstly, I will try to explain some of the formulas that we will be using in problem solving. So the first formula would be cycle time. This is operating time per day divided by desired output rate. And then the second formula is n minimum. So this is the minimum number of workstations. So that's given by the sum of all the times for each of the tasks divided by cycle time. So this is T is the task time and this is sum of all. So this is sum. And then the third formula is percentage of idle time, which is given by idle time per cycle divided by n actual multiplied by cycle time and then multiplied by 100. So n actual is the actual number of workstations used. Actual number of workstations used. And then we have efficiency, which is given by 100 minus percent idle time. So that is, we take this value and put it here. So these are the formulas which we will be using to solve our problem. So let's look at the problem and solve this problem. So using the information contained in the table shown below, do the following. Draw the precedence diagram. So the first question, I will try to draw the precedence diagram. So in line balancing, mostly you have tasks. Here the tasks are A, B, C, D, E, F, G, H. And then the immediate predecessor means this task should be finished before the other task starts. For example, here B has immediate predecessor A. That means A should be finished in order for B to start. So to draw a precedence diagram, so if you see the first one, I take A doesn't have any immediate predecessor, so I will draw A. So now the second one, B has an immediate predecessor of A. So in order for B to start, A should be finished. So for C, if you see, there is no immediate predecessor. So C doesn't have any immediate predecessor. So in order for D to start, C should be finished. So in order for D to start, C should be finished. In order for E to start, B should be finished. So this is E will start after B. in order for F to start, both D and E should be finished. So in order for F to start, D should be finished, E should be finished. In order for G to start, F should be finished. So in order for G to start, F should be finished. In order for H to start, G should be finished. So this is how our precedence diagram looks. So I will put the task times for each of the tasks also. So this is A takes 0.2, B takes 0.2, and then C takes 0.8, D takes 0.6 minutes, and then E takes 0.3 minutes, F takes 1 minute, G takes 0.4 minutes, and then finally H takes 0.3 minutes. So this is question 1. So for question 2, if you see, so I'm done with question 1. Question 2, assuming an 8-hour day, compute the cycle time needed to obtain an output of 400 units per day. So now they are asking us to calculate the cycle time. So if you see the formula for our cycle time, which we discussed in our previous page, cycle time is the operating time per day divided by the desired output rate. So cycle time is operating time per day divided by desired output rate. So the operating time is given as 8-hour work day. So that means I will convert, because our tasks are given in minutes, I will convert it into minutes. So 8 hours multiplied by 60 minutes per day divided by the desired output is 400 units per day. So our cycle time will be 480 divided by 400. So this is going to give us 1.2 minutes per cycle. So what it means is every 1.2 minutes you will get one product out of this system. So we are finished with 2. For 3, it says minimum number of workstations required. So we have to go back and again look at our formula for minimum number of workstations. So the minimum n minimum is sum of all the task times divided by the cycle time. So our question 3 would be n minimum is sum of all the task times divided by the cycle time. So if you see, the cycle time here is 1.2 minutes. So this will be 1.2 sum of all the task times. That means I need to add all these. So 0.2 plus 0.2, 0.4, 0.4 plus 0.8, 1.2, 1.8, 2.1, 3.1, 3.5, 3.8. So this is going to give us, so the sum of 0.2, 0.2 plus 0.8 plus 0.6 plus 0.3 plus 1 plus 0.4 plus 0.3 divided by 1.2 is our minimum number of workstations we need. So this will be 3.8 divided by 1.2, so that's 3.17 workstations we need. So because we can't have 3.17, we will round it off to the greatest value, which is 4. So try to round to the greatest value because this is minimum number. So 4 workstations is the minimum we need. So the last question, no, this is the fourth question. Assign workstations using this rule. Assign tasks according to the greatest number of following tasks. In case of a tie, use a tiebreaker of assigning a task with longest processing time first. So I will do 4. So they are saying I have to assign tasks to workstation. So the rules they say is the first rule which they are telling us is assign tasks according to the greatest number of following tasks. So the first rule is greatest number of following task. So in case of tie, they are asking us in case of tie, use the tiebreaker of assigning the task with longest processing time first. So if there is a tie, we will choose the task with longest processing time. So I will try to draw this diagram again for our convenience. So the diagram 1, precedence diagram. This is A, then I have B, I have C, I have D, E, F needs both D and E, and then G needs F and H. And then I will also put the tasks, the task times on the in this diagram. So A is 0.2, B is 0.2, and then C is 0.8, D is 0.6, E is 0.3. So this is E. F is 1, G is 0.4, and H is 0.3. So now we wanted to assign these tasks to workstations. Let me cross check with this. Okay. So to do this, I will draw a table. So the table would consist of station. So this is workstation, and then we will have time remaining, and then eligible. So these are eligible tasks, and then assign task, and then we have revised time remaining, and then we will have idle time. So each workstation, if you see from our previous calculations, each workstations will have a cycle time of 1.2 minutes, and then we will have 4 workstations. So the first workstation I will have 1.2 minutes. So the eligible is here what tasks are eligible. So if you see, I have A which doesn't have any immediate predecessor, and C, so A and C are eligible. So now I have to assign task, and to assign task they said greatest number of following tasks. So that means for A I have 1 which is B, E that's 2, 3, 4, 5 tasks which are following A. So 5 tasks are following A. And how about C? 1 which is D, F which is 2, G 3, 4. So 4 are following C. So obviously I would assign A because I wanted greatest number of following tasks. So I assign A. A takes 0.2 minutes. So the time remaining is this is the amount of time I would require now is I'm left with 1 minute. So I will, so the time remaining I will transfer that here. So the next step is, now I am done with A, so this is done. So the next eligible would be, because A is done, B can be started, and then C. So now if you see the following tasks for B, 1, E is 1, F is 2, G is 3, H is 4. So 4 are following. For C also 4 are following. So in the case of tie, it says longest processing time, you will choose that. So if you see, B has a processing time of 0.2 and C has 0.8. So I will choose C because it has more processing time. So that is 0.8. So I am left with, if you see, out of 1 I used 0.8, I am left with 0.2. So I will use 0.2 here. So now I have, so I'm done with A and C. So I'm done with this, I'm done with this. Now my next is B and D. So again I have B 1, 2, 3, 4 following, for D 3 following. So for this 4 following, which is E, F, G, H, and for D, F, G, H is following, so 3 tasks are following. So I will choose B, which is 0.2. So I'm done. So I will be left with 0. So my idle time for this workstation would be 0 because I used the entire time. So now I will have second workstation. I will start again. I will have 1.2. So now I am done with B also. So this is also done. So my next would be D and E. So if you see for D and E, I have for D I have F G H following, for E I have F G H following, so both have 3 and 3. So in the case of tie, we will use the highest processing time. So if you see, the processing time of D is 0.6 and E is 0.3. So I will assign D, which has the highest processing time, which is 0.6. So I'm left with 0.6. So I will transfer here 0.6. So now I have only E, because in order, I can't use F, because in order for F to start, E should be finished. So E, I will directly assign E, which will take 0.3. So I will be left with 0.3, and then I will transfer 0.3 here. So 0.3, if I transfer here, now I have F, which is eligible. However, F takes 1 minute, so I have 0.3 left. I can't assign that, so I will just get rid of F here, and I will start F in a third workstation. So here my idle time would be 0.3 for the workstation 2. So for workstation 3, I have again 1.2, and I have F as eligible, which takes 1 minute. So I will assign F, so it's 1 minute. So I will be left with 0.2. So if you see, my next eligibility here would be G, which takes 0.4, and I have only 0.2, so I will just move to a new workstation. So here my idle time would be 0.2. So now I have again 1.2, the eligibility is G. I will assign G, which takes 0.4 minutes, so I will be left with 0.8. And then I have 0.8 minutes, so I will use H, which takes H, I will assign it, which takes 0.3, so I will be left with 0.5, so this will be 0.5. So this is how you are assigning the workstation. So the total idle time, if you look at this, would be around, for this whole process, would be 0.5 plus 0.2 plus 0.3, which is 1 minute. So if you see, I am assigning ACB as the first workstation to the first workstation, DE to the second, F to the third, and GH. So if you want to draw here, I am doing ACB, so that is, so this will be my workstation 1. So I will write workstation 1 as WS1, and then DE, this one is my workstation 2, and this is my workstation 3, and this is my workstation 4. So that's how I will be assigning the workstations. Now the final part of this question is to, so if you look at the question, is to compute the percent idle time and efficiency. So percent idle time, our formula, if you see, it's idle time per cycle divided by n actual multiplied by cycle time multiplied by 100. So the thing is, n actual, here we used 4 workstations. So we have 4 workstations, that would be our n actual. So we have workstation 1, workstation 2, workstation 3 and workstation 4. So let me use the formula, which is percentage of idle time is idle time per cycle divided by n actual multiplied by cycle time multiplied by 100. So idle time per cycle is 1 minute. So I will just write percent idle time like this. So this is 1 minute divided by n actual. I have 4 workstations I am using. Each workstation is taking 1.2 minutes. So 1.2. So this is 1 multiplied by 100. So if you calculate this, you will get 20.83%. And then finally efficiency is 100% minus percent idle time, which is 20.83. so this is going to be 79.17%. So this system, if we have a workstation assigned this way, the efficiency will be around 79.17%. So this concludes my lecture on line balancing. Thank you.